Maxwell Mesh Analysis. What is Maxwell Mesh Analysis? Well, Maxwell Mesh Analysis is a network analysis technique where mesh or loop current directions are assigned arbitrarily, and then Kirchhoff's voltage law, KVL, and Ohm's law are applied systematically to solve for the unknown current and voltages. Here's a sample problem to understand Maxwell Mesh Analysis. Determine all branch currents and the voltage across the 5 ohm resistor by loop current analysis. Applying the KVL for the loop ABCDA, the loop is passing through 3, 5, and 6 ohm resistors, and it touches negative terminal of the battery of 50 volts. The 5 ohm resistor is common to loop currents I1 and I2. For loop 1, the current I2 in 5 ohm resistor is opposite to the I1 current. Hence, loop 1 equation is 3I1 plus 5 times the difference of I1 minus I2 plus 6I1 minus 50 equals 0. To simplify this equation, we have 14I1 minus 5I2 equals 50. Similarly, for the loop BEFCB, the loop 2 is passing through 2, 8, and 5 ohm resistors, and it touches positive terminal of the battery of 25 volts. The 5 ohm resistor is common to loop currents I1 and I2. For loop 2, the current I1 in 5 ohm resistor is opposite to the I2 current. Hence, loop 2 equation is 2I2 plus 8I2 plus 5 times the difference of I2 minus I1 plus 25 equals 0. To simplify this equation, we have negative 5I1 plus 15I2 equals negative 25. So here's the two simultaneous equation. To cancel I2, we have to multiply equation 1 by 3 and then adding with equation 2. The sum of 42I1 minus 15I2 equals 150, and negative 5I1 plus 15I2 equals negative 25 is 37I1 equals 125. To solve for I1, we have to use the formula voltage over resistance. 125 over 37 is equals to 3.3784 amperes. For I2, we have to substitute 3.3784 to I1 to find I2, which is negative 0.541 amperes. The branch currents are calculated using Ohm's law, which is voltage over resistance. So the answer is also 3.3784 ohms. The current IEB is 0.541 ampere because it is defined as the negative of I2, which reflects a direction change. This happens when the current direction in the second mesh is opposite to the current direction through the specific component between points E and B. The current through the 5 ohm resistor IBC is the difference between the mesh currents. So the answer is 3.9194 amperes. Now, the voltage across the 5 ohm resistor is calculated using Ohm's law. V equals 3 times IBC. Substituting the values, we have V equals 5 ohms times 3.9194 amperes. So the answer is 19.597 volts.